I'm Bob Page from the Manual Ventilation Academy, creator of the course High Performance Ventilation. And I got a question for you all today. Can you ventilate? Let's look at the standard bag valve mask. This is the Ambu Spur 2, and this is a fully loaded one, as I like to say. So what it has on here, first of all, of course, bag is here, the one-way valve is here, and the mask is the part that goes down here. So that's why I call it a bag valve mask. So anyway, it's a one-way valve, so when you squeeze the bag, it forces the air through this valve and it goes down there into the patient. Now, if you know, the EOlife is going to go right here at the end of it, and it's going to measure, when you squeeze the bag, it's going to measure the air that's going through the sensor here, where the sensor is. And so this would be on the mask like this. So here's how you assemble the device. You have the bag there, and then it goes into the EOlife here, and then it goes into the mask. And of course, you can see you can swivel it to make it comfortable. So if I'm ventilating like this, I can get to where I can see it right here. So it's right here looking where I can see straight down on it and give me the ventilation. So to activate the EOlife X or the EOlife, push the on button. Screen goes through its self-test. And then we're going to choose adult. If you notice, you got 3 different sizes of adults. So the tall is basically from about 5'11" to 6'7". We'll click on tall for this one. And we're going to go with continuous mode, which is asynchronous. And we're going to do monitor ventilation. So we click on the monitor ventilation tab, and now it's ready. So as you see the arrows pointing to the lungs, that shows you when you need to squeeze the bag to to ventilate them. So you can see the feedback bar goes up there. You want to try to get it in the green, just like that. Now if you notice, you see a VI and you see a VT. You have inspiratory volume, and you also have tidal volume, which is coming back through here. So you see if they're within about 15 to 20% of each other, it'll mark you as a good ventilation. As you can see, it also helps control your timing this way as well. 2, 1, ventilate. We're getting a correct tidal volume for this person's size and a correct inspiratory volume as well, without much leakage at all. Now what happens if I get a poor mask seal? So I'm going to loosen up on the mask to make a leak on the mask here so you can see it. So as you see, the tidal volume went in, but the inspiratory volume went to 574, but the tidal volume jumped off altogether. So see, even though we put the right amount of air through there, as you see, only 232 came back on this one. So this mask leakage is very important, because if you get a mask leakage and you're not having a tidal volume, you do not deliver the proper amount of oxygen to the patient, and you do not remove the proper amount of CO2. And on top of that, your capnography is not going to work either, for the simple reason it didn't get a full tidal volume breath. So as you see this occurring here, you want to try to either readjust, get a different mask seal going, and see if you can overcome it with your next couple of breaths. If you notice, my frequency there is 10 a minute, so I'm keeping right with my timing there. What would happen if we gave too much volume? Now watch this next one, how the feedback device tells you. See there, I just squeezed a bag with one hand, got 860 milliliters in. Now what happens if we don't get enough? Now we get an insufficient volume alarm there. We don't squeeze it enough. See, I'm squeezing this adult bag valve mask here, and I'm getting just a little bit at 280. It's 288 right there. That's what a pediatric bag valve mask would do if I squeeze that one. So, it's very easy to get too little out of a pediatric one. It's easy to get too much out of an adult one. But with an adult bag valve mask, it's very hard to get too little with it, unless you're trying not to put air in them. So that's why a feedback device is important. So whatever bag valve mask you choose to use, you have to have a feedback device, or either one of them you won't know which way to go. So tidal volume is absolutely important. Leakage is absolutely important, because with important leakage, that means that you're not delivering oxygen to the patient, you're not getting CO2 out, and your capnography is not going to work. And so this is very important to get rate, volume, and pressure down on these mannequins here, or in the real patient, of course, as you can see that right there as we ventilate. But again, it's how you practice with it. Now again, what your students will learn with this as you're going through these feedback paces here, they're going to learn really quickly that it's hard to hold a mask seal that long. Also, if possible, you want to have two-person bag valve masks because it's easier for one person to hold the seal at the same time someone else is ventilating. So if you have the ability to do that, definitely do that. In the class, we actually show you how it works when we put airways in, such as the iGel or the King or the LMAs or something like that. We show you what it's like in the class actually ventilate using those devices. And so that's basically for the adult ones. So once you're done, you get feedback on this, and as you can see, it shows you here the ventilation we were doing. Since we kind of played around a little bit, only 27% were correct. Our rate was a little bit slow. We did it for 5 minutes, and of course, out of everything we did, we averaged about 271 milliliters. So you can have more detailed feedback with the app that comes with the EOlife X device. You can download this to your tablet and get all the feedback, which gives you a graph form that shows you all these things broken down. But so you can get the feedback right there. With that, there's something else I would like to show. Is that, let's say, for example, you got a pediatric patient. So if you've ever heard of the Antevi system, the Antevi system, as you're going to the call, you're getting prepared. So, for example, you get a call for a 3-year-old that might have been involved maybe in a drowning. So as you're going there, you're thinking about the size of the airway, the dose of epinephrine, defibrillator dose you're going to be using. So if you got a child, you can also turn this on while you're getting set up and everything before you get to the kid. Now, it says child size. And if you notice here, it gives you an option there, and look, they're color-coded just like the regular Antevi system. So a 3-year-old, we're going to choose this one, and we're going to do continuous. And now it's going to adjust it for a kid size here. Now, you can see real quick, it's going to not take much to get over that amount, and I'm trying to do it with an adult bag valve mask. See, it's not going to work. So adult bag valve mask is not going to work on a child because I can't even control just that much. That's barely squeezing it at all. So you'd want to have a smaller one. But do you see how this can actually show you on a child too that you're getting the right ventilations as well? And the computer inside here, the algorithm actually adjusts it to the correct size of the kid. So whenever you choose their size by their age, like the Antevi system does, then you'll be able to see really quick how you can adjust ventilation just like you would on an adult patient right there as well. And so it works for adults and peds. Remember, this device, the EOlife, is FDA approved at this moment here for adults only, but it's in the works for children. But for training, this is incredible training tools for PALS, for PEDS, ITLS, and things like that, where you're working on these pediatric courses. We have pediatric mannequins. You can ventilate the same way with those. But again, just to let you know, this thing is for age 1 all the way up to adult size you can choose from. At the same time, the device also shows you the volume coming in as a bar graph that comes across, and you can see it that way as well. So that's one feature. So to let you know how the device actually works, when you squeeze, the air comes through there, it measures the volume going through, but it also measures the air coming back out. And so if that equals, then it's going to give you a good ventilation, which is what we want. Remember, if you're using end-tidal CO2, and if you know what other classes I teach, my capnography course has been going for 25 years. And you know about capnography. Capnography requires a tidal volume breath because the first 150 milliliters that comes out of your body is going to be dead space. There's no CO2 in it. The next 150 that come out or so is going to be what they call physiologic dead space. It's going to be a mixture of both the alveolar CO2 and the dead space. So it's not going to be the true reading. It's only at the end of a tidal volume breath, and on the average adult, that's about 500 milliliters. At the end of that tidal volume breath is where the alveolar CO2 come out. So if we have a mask leak, if we have a leak in the iGel, when we ventilate the patient, the air goes in, but it leaks, it doesn't come back up through, not only where your CO2 reading is going to be low, but you're going to get a leakage alarm. But the problem with the CO2 being low is it wasn't measured correctly because it never made it to the capnograph. Remember, the capnograph's up here is a little port on this Ambu Spur 2 that you can plug into that goes to your regular monitor, your Zoll X series, your LifePak 15, your LifePak 35, even your Philips Tempest. It'll go right into the same plug-in that your regular cannula does. You don't have to have the little adapter here, make a stack about 10 feet tall. It plugs right in there and goes right to your machine. So as you're ventilating, the capnograph is being measured at the end of it all. So if you get a mask leak here, then the same volume is not going to make it to the capnograph, and now your capnograph is not going to read correctly. And so again, another reason why it's important that you have this feedback that tells you a leakage. That leakage can occur, number one, mask seal's bad, Number 2, your IGL got twisted or something. Number 3, you got a leak in your endotracheal tube cuff. That could happen too. And so these things are all problems you can encounter, but with feedback, you won't do them over and over again. You'll know immediately at the time it happens to correct it. And so again, this should make common sense to everyone, the fact that we need to have some sort of feedback on this to tell us. So now you see with the volume and the leakage alarm cursor, because both of those have to do with tidal volume. We want an adequate volume going in, we want the tidal volume coming out, and through the leakage alarm, it can show you that you're not getting the adequate tidal volume one way, that it's leaking, but another way, you can actually read on the readout there what the tidal volume actually is. This measures VI, inspiratory volume, and VT, tidal volume that comes back. So that's the volume part. What about the rate? Well, these devices have a graphic interface that shows you 2 arrows pointing to the lungs, and that tells you when to ventilate the patient. And so these things are preset for the standard AHA rates that they give you when you take your courses, when they give you the standard guidelines. Typically most people, experts agree, about 6 to 8 milliliters per kilogram of ideal body weight is how much volume you're going to give them. So depending on how tall they are, how long they are, then you're going to find out real quick how much you should actually give, because you can select it on this device, and the device will adjust itself for that particular tidal volume for that particular size of individual. The EOlife X also has the ability to train on pediatrics. It's color-coded along with the Hentevi or Broslow system is color-coded, that actually, as you choose a 1-year-old child, it actually adjusts itself to a child that size, so the volume, again, is going to be measured with real-time feedback. You just choose the correct size, it'll give you feedback as to what size that particular individual needs. And so that's another thing that technology has given us. So we've got volume in here, we've got time in there. The last thing we want to look at is pressures. When someone's not breathing on their own, what ends up happening is you get the weight of the chest and also the airways are relaxed. And so to put air in someone who's not breathing on their own, that's an unnatural act, because we draw air in actively with negative pressure. So our chest rises, makes a negative pressure, we pull the air in. If you're not breathing at all, you have to push air in their lungs, and that's called positive pressure. And so it does take some pressure to overcome the natural resistance to airflow in your body when you're unconscious and you're not breathing. So when someone is not intubated, so a non-invasive airway, they're not intubated, you don't have any airways in, the ventilation pressure, the PIP, or the PIP if you will, the positive inspiratory pressure, that pressure needs to be kept less than 20 centimeters of water. Now, a manometer is another device that you can get added onto your bag valve mask. This one is on this ambu spur, plugs into the side right there, and every time you squeeze the bag, you'll see the gauge go up. On the non-intubated patient, non-invasive ventilation, you want to keep that less than 20 centimeters of water. Why? If you get above 20 centimeters of water, you have an esophageal sphincter, that pressure will open it and the air will go in the stomach rather than in the lungs. And so that's not a good thing. And even an oropharyngeal airway or nasopharyngeal airway can't stop that. The only way you're going to get around that is to isolate the esophagus by putting in an IGL or a king or maybe an endotracheal tube, and that way you're pretty much assured it goes in the right place. Once you do have them intubated with an endotracheal tube, the manometer easily can go above 20, which it will, because the pressure goes straight to the lungs. That's okay. We want to keep it less than 30 if we can, because less than 30 is pretty much a safe zone for the lungs. You can do lung protective ventilation as long as the inspiratory pressure stays below 30. If the person's got an IGL or a king airway or supraglottic in, then you get it usually between 20 and 25. Works really good with those. So you see there's kind of a stair step. If someone's not intubated, just a bag valve mask in the natural airway structures, usually less than 20. With an IGL, 20 to 25. With an endotracheal tube, 20 to 30 on the manometer here for your inspiratory pressures there as well. So you see the pillars of ventilation are starting to show up now. We have the volume and the rate here, we have the pressure here. So this device I'm holding in my hands right now is the equivalent of having a mechanical ventilator. But the only thing applying the power is your hands. Squeezing the ventilation device, because you're measuring rate, volume, and pressure. You just control it here rather than pushing the buttons to control it another way. And again, many people are starting to buy automatic ventilators for the simple reason is that they can't control this. If we could control this, we'd have no need for ventilators. But on long-term transfers, it may be hard to squeeze this all day long, but on short-term transfers, you're less than 20 minutes away with an EOlife and a capnograph. You can squeeze in a manometer, you can ventilate like this for a long, long time. And doing through that, again, what's the key here? It's the feedback on the tidal volume. It's the feedback on the rate. It's the feedback on the pressure. All parameters of high performance ventilation that now we have available. Unfortunately, most places that I've seen in my classes, they have what we call a naked back valve mask. It doesn't have anything on it. It's just this device, and there's no way to measure pressure, no way to measure volume, no way to measure time at all. That's what they give us, and we think, well, okay, that's all we got. We'll go with chest rise and fall, which we know doesn't work. So for a little bit more, you can outfit your device with the manometer and even a PEEP valve on the end and the EOlife here, and then you have a totally different device to ventilate with. And by the way, I don't know how it is in your state. In the Commonwealth of Virginia, the only person who can use an automatic ventilator is a paramedic level with special skill designation to work a ventilator. Which means in some services, it's probably going to be just the 2 or 3 people that on a special car that carry it around with them. But for one of these devices, with the EOlife, anybody, including EMTs and first responders, if you're allowed to ventilate a patient like this, you're allowed to use everything that goes with it. So you see, this is the perfect device, since most of our providers are probably EMT basic level or first responders, but even paramedics have to do manual ventilation. So this is the perfect device to actually do that. So again, how it's set up is pretty simple. You know, all comes separate. You get it out of the bag there. First thing you do is put the EOlife on the device like this, and then put the mask on, and put your mask seal on there, and you're ready to start ventilating. Now we'll go over the actual controls on side of the device right here, but see, it just goes between the bag valve mask and the bag. So it goes between the bag and the mask. There is where the EOlife goes. And now you got your ventilation rate, and with your manometer, you got your pressure right there in one little package. And so again, this is the device here. This is the device that actually puts the P-back in CPR, because it gives you full real-time feedback. And that's why they call it the ventilation feedback device. It's the one tool we've never had before until now. And so the EOlife X is for trained, the EOlife is for regular patient use. Again, the EOlife is the only FDA-approved device for measuring tidal volume in an adult patient. So that's what makes it stand unique here with this particular device.